Good morning, guys. Somebody would like to wave hello to you. That's Grace right there. Okay, big debut. We're gonna have a new family member next week, though, so I'll make sure that we have a little video to introduce you. It's as much as I'll tell you for right now. All right. With the notes for today, they are a little lengthy, so I'm gonna only do maybe like every other example, but the full notes are on the website, so go take a look. Pause the video anytime you need to. I would like to actually do the warm-up because it says sketch the graphs of sine of x, cosine of x. So we kind of just say like, hey, here's the graphs, and then bam, you have to jump into them. So I really want to make sure that you are comfortable with what the basic parent functions look like before we go messing with the graphs. You definitely need your calculator today. So if you don't have it next to you, pause the video, go get your calculator. All right. So the first part, when it just says sketch sine of x, sketch cosine of x, if you already look, the x-axis is labeled from 0 to 2 pi, y-axis from -1 to 1. So as a reminder, I said you have to basically plot those 5 like anchor points, right? You can absolutely use your calculator to help you graph it. You could set up the window to match, right? But the 5 points that you need to plot for sine is that sine starts at 0, 0. It finishes at 2 pi, being at 0, and dead center at pi is also at 0. So increments of pi hit 0. Then it's going to go up to +1 at pi over 2, down to -1 at 3 pi over 2, and then as pretty as you can, connect the dots. If you want to use your calculator to help you, you can either set the window or you can go to Zoom Trig, and you have to remember to be in radian mode. We talked about that in yesterday's video. All right. For cosine, same idea, same 5 anchor points, but it's shifted over. For cosine, it starts at 1, it finishes at 2 pi at the same height of 1. Dead center, you're down at -1. And then halfway between 0 and pi is when it hits 0, so at pi over 2. Halfway between pi and 2 pi, at 3 pi over 2, it hits 0. And then connect the dots with a nice curve here. But absolutely use your calculator to help you, okay? So when it says for each of the graphs above, what's the amplitude, what's the frequency, the period, the phase shift, and the midline, all right? The amplitude, is the stretch. There is no stretch here. There's no value written in front of sine other than just 1. So the amplitude is 1 for both of them. The frequency is the number in front of the x. So again, that's just a 1, right? Meaning you see 1 cycle from 0 to 2 pi. Period is the length of 1 cycle. And so for each of these, they start at 0 and end at 2 pi. So the length of the cycle is 2 pi itself. The phase shift, that's if we saw anything plus or minus inside the parentheses, and we don't, so that's 0. And then the midline, that's the line that literally slices right through the middle of each graph, which in these are is the x-axis or the line y equals 0. And it would also be if there was any value added out to the end, and there's not, all right? So the midline is always that horizontal line right through the middle, all right? What we're gonna do for today's notes is it's basically like a little calculator, like, let's see what happens, is you're gonna change the values of the amplitude and the frequency and kind of see how that affects the period. But we're gonna start by just messing with the amplitude. Right? If you'd like to do all of them, remember, just pause the video, try them all, and then watch and we'll do the conclusion, okay? Otherwise, when you slide on down here, you slide this up. There we go. All right. What you need to have here says use your calculator, and you're going to graph each function from 0 to 2 pi. So I want to set up your window so that we're only looking at from 0 to 2 pi, okay? So if you were on Zoom Trig using up above, right now I want you to go to your window, and I want you to go from the x minimum at 0 to the x max at 2 pi. It's automatically going to change to that decimal equivalent of 2 pi, and that's fine. For the scaling, I want you to use pi over 2. So if you type in pi over 2, it's going to change to about 1.57 whatever, because that's what pi divided by 2 is. Right? As for your y min and max, -4 to +4 is probably the best place to be, right? Then this way you'll be able to see everything. Okay, so for the first one, what I want to look at is I have sine of x in there from yesterday, so I can graph that guy first. So there's my basic old sine curve. And now for part A, it's asking you to graph y equals 2 sine of x. I'm actually going to leave sine of x in there and then do 2 sine of x in y2. It's kind of nice to see them simultaneously so you can see how the graph changed. So if you look, it's stretched, it's going up higher, it's going down lower there. But where it hits zeros is exactly the same. So it hits 0 at 0, pi, and 2 pi. And then it's going up to a height of 2 and down to a low of -2 here. All right. When you go to do the next one, feel free to put it in y3. Or if you want, I'm going to leave sine of x in y1, and I'm going to make this just -3, and then sine of x in my y2. So when we graph this guy, here's sine of x first. Give it a second. All right, and then here's -3 sine of x. So it's much more stretched out and also flipped over. We know that that negative reflects it over the x-axis. So a couple things going on here. So when you look at it, though, where does it still hit 0? 0, pi, 2 pi. So plot those points first. And then at pi over 2, it's going down to -3. And then at 3 pi over 2, it's going up to +3. Right. As for the next two, they're cosine graphs. So if you do those ones, you just have to keep in mind that you're comparing it to the cosine curve. So I'm going to skip those. Feel free to take a look at those on the notes, but these two get across the point of what we need to see here, all right? Because what the amplitude for this one, that's 2. Something to keep in mind. The amplitude is that number out front, but we always say that amplitude is a positive value. So even if I see -3, I want you to think of it as the absolute value of that. We would just be +3. Okay. What's the range? Well, this graph, instead of now going back and forth from -1 to 1, goes 2 to 2. This one goes from -3 to 3. Okay. So what our conclusion, hopefully, should recognize is the fact that, yeah, it's that vertical stretch. It's going to take the graph and stretch it from top to bottom. Okay. So the amplitude is a vertical dilation. I also want you to keep in mind that we always consider it to be positive. But what does that mean then if it's negative? If it's negative, you're reflecting it over the x-axis, right? And then we could also say that the range always goes from whatever -a to +a is. Okay. So if that's all we're changing, of course, that can change depending on if we mess with some other stuff. But for today, if the amplitude is 2, then the range is -2 to 2. If the amplitude is 5, the range would be -5 to 5. There you go. All right. At the top of the next page, now we've got a different set of values that we're going to mess with here. This time, we're going to change the coefficient in front of the x. So here we make it a 2, a 1/2, a 4, a 3. Okay. So for this one, because we had, oh no, I guess I still want to stick with the sine ones. I was going to say because we did sine last time, let's do cosine this time. But I specifically would like to look at the sine ones because of this coefficient that's 1/2. I think that one's important to see. So let's do the first two again. All right, so if we do sine of 2x, back in your calculator, good thing is, whoops, keep sine of x in that first spot so that you can see what the basic sine curve looks like. And then I want you to right beneath it, put in sine of 2x and then hit graph. Keep in mind, I know I'm not with you, so if anybody's having any issues getting the graphs to show up, forget, you might have to turn your stat plots off or something goofy like that. So, pay attention to whether or not those things are on. And if you can't figure something out, just shoot me an email. All right. Otherwise, the blue graph was the sine curve. The red graph is the sine of 2x. So when we change the frequency and make it a 2, right, what we're seeing is that there's more cycles now. So to graph this, we are starting at 0, but if you look, we're hitting 0 at every tick mark. Every tick mark represented an increment, there's the word I was looking for, of pi over 2. So at pi over 2, pi, 3 pi over 2, 2 pi. And now if you look at the height didn't change any. It still goes 1 to -1. So if I go to my graph, there's 1, there's -1. How do I figure out where to plot it? Well, it's symmetrical. That's the beauty of these graphs. So if I'm hitting 0 at 0 pi over 2, dead center between them is when it should be hitting that height of 1. So it's going to be halfway between those ones in the middle of that box. Now come halfway between these two, I'm down at -1. Halfway again, +1, halfway, -1. And then connect the dots. All right. So when it asks what's the frequency, that's this value right here. That's the B, all right? That's 2. What's the period? The period is the length of one cycle. So I'm going to grab my fancy red pen over here. And if I highlight over just one cycle means that I've finished the curve and before it starts to repeat again. So this piece of it is simply just one cycle, right? So what's the length of that? Well, it starts at 0 and it ends at pi. So the length of it is just pi itself. Pretty easy to see it in this example. If it didn't start at 0, you would take the end point and subtract the start point. So you would do like pi minus 0 and get pi. All right, but that is the length of the cycle. And then the last part, what's the range of the graph? Well, the range is going from -1 to 1. Okay, for the second one, go into your y equals, keep sine of x, and now let's change this one to sine of 1/2 x. All right, graph them side by side. So there's our sine of x. Sine of 1/2 x looks a little funky. It almost looks like you've got like this upside down parabola or something, but you have the same curve. You're just only seeing half of it. So the frequency or the B value is the 1/2 there. And what that represents, that's representing how much of the curve you're seeing between 0 and 2 pi. So when you go to graph this, it starts at 0. It hits 0 again way over here at 2 pi. Because it's symmetrical, it's hitting the top at the halfway point, which is at pi. So at pi, it hits the top at 1. You're going to do your best to draw a nice, smooth curve. So it looks like that. So think to yourself, how much would you have to, or how far out would you have to look to see the whole curve? Well, I'm only seeing half of it from 0 to 2 pi. I'd have to double that. I'd have to go all the way to 4 pi. And if you want to just look, you don't have to change it on yours. If I actually change my y maximum to 4 pi, or excuse me, x maximum to 4 pi, and then hit graph, the red graph is the one we're focusing on. There we go. There's the whole cycle right there. So I'm going to change my window back to just being 2 pi, but I just wanted you to quick see that. So the period is 4 pi, all right? Because you're only seeing half of the cycle right here. As for the other ones, we can at least talk about what would happen here. The frequency here is 4. And so what that means is you'd actually see 4 cycles. The frequency here is 3. So you'd see 3 little cycles between 0 and 2 pi. So what that actually means, right, is the relationship between how many cycles you see and, sorry, I had a brain fart there for a second. The number of cycles you see in that little chunk of 2 pi, you can actually calculate the period, all right? And so what I mean by that, if you look at it, like the period for the parent function would typically be 2 pi. Because we're seeing 2 cycles here, you take this and you break it into 2 parts. So that's the length of one cycle. Think about this one. If 2 pi is the length of a normal cycle, and we're only seeing half of it, if you divide it by a half, anytime you divide by a fraction, the same as multiplying by the reciprocal, that would actually give me 4 pi. Right? So for this one, even though we didn't draw it out, if you can imagine seeing like 4 little cycles going on here, 2 pi divided by 4, the length of just one would be pi over 2. Right? The range for all of them, though, is all -1 to 1. We didn't change a darn thing with that. Right? So under the conclusion part, what I want to look at is the b value, is the frequency. So it's the number of cycles you see from 0 to 2 pi. And then as for the period, how you can always calculate it, because it represents the length of one cycle, is simply just to take 2 pi and divide it by whatever b is. And that'll tell you what the length of the cycle should be. All right, so that's the big kicker with this lesson, is what is amplitude doing? How is it changing the graph? What is the frequency? And then how does it affect the period? All right, because when you go to graph these ones, you have to be able to understand those details. Before we get to a graphing one, down at the bottom, let's do one of these guys. So it's saying for each, find the amplitude, frequency, period, and range. All right, so the very first one, remind yourself, this is in the form of a sine of bx. So when it says what's the amplitude, frequency, those ones you don't really have to think too hard about. Simply, the a, or the amplitude, is just the 6. The b, or the frequency, is the 4. Easy. All right, for the period, this you have to calculate. So if the frequency is 4, it means I'm going to see 4 cycles between 0 and 2 pi. So the length of each cycle, you take 2 pi and you divide it by that value. So each little cycle will have a length of pi over 2. Ta-da! Last part, the range. If you remember back from the first page, if the amplitude's 6, the range is going to then go from -6 to +6. That's it. Cool. All right. I said we were going to do one. I fibbed. We're going to do part B because this one's different enough that I want to look at it. But let's do the first part quickly. Here's A. Here's B. So the amplitude, 8. The frequency is pi over 3. Now, I know that sounds weird, but pi over 3, it's a little bit more than 1 because 3.14 divided by 3. So they're saying you'd see a little more than 1 cycle from 0 to 2 pi. That's what that actually means. Okay, here's where it can get interesting. The period, we're going to do 2 pi divided by pi over 3. Remember, complex fraction, multiply by the reciprocal. When I have 1 pi in the top and 1 pi in the bottom, they actually cancel and I get 6. So the period, or the length of it, is just 6, which means when you go to graph it, I wouldn't have to label the x-axis with pi over 2, pi, 3 pi over 2, and so on. I would just label it with 0, 1, 2, 3, 4, 5, 6. When we see like word problems in the future, yep, those are coming. That's the type of thing that you would see. Because we are not going to talk about pi over 2 number of hours. That's weird. You're going to talk about 6 hours and so on. All right, last part. The range would just go -8 to +8. Bam, done. Okay, on the back. Or the last, these ones, I like these because I think they're fun. Anything that's puzzle-like, that's my jam. All right, it says determine an equation for each of the graphs shown below. So what you have to figure out is, okay, what do you think? What do you think the equation of this thing is? So really what I'm asking you to do, I'm asking you to figure out, 1, do we think it's sine or cosine? 2, what's the amplitude? 3, What's the frequency? All right. Those are the three things you're kind of asking yourself here. How do you figure those out? First things first, for sine, if it starts at 0, so 0, 0, that would be sine. Cosine, if it starts not at 0, or literally off the x-axis, that's code for it would be a cosine function. Amplitude, then you're just going to figure out how far up and down is it going. Frequency, how many cycles are you seeing from 0 to 2 pi? Right? So when you look at this first one, what I'm going to do is I'm going to use my red pen again. I'm just going to highlight one cycle. So if I start at 0, one cycle goes up, comes back to 0, goes down, comes back to 0. That is one cycle right there. All right, just this little piece. All right, it starts at 0, 0. So if it starts on 0, I'm going to use this as a sine curve. So it's going to be sine. Now I have to figure out what's my amplitude, what's my frequency. So this is going to be my A, that's my B. All right. The amplitude, when I'm looking at it graphically, it's the distance from the middle to the top or the middle to the bottom. So how high up is it going? So that's going up to 3, down to -3. So my amplitude has to be 3. And then the last part, how many cycles do we see from 0 to 2 pi? Well, there's one cycle from 0 to pi, and then a second cycle by the time we get to 2 pi. So there's 2 cycles from 0 to 2 pi. How can you check this? Get your calculator out, type it in. Does it look like it? That's a pretty easy way to do it. So for part B, when you look at this one, ask yourself those same questions. Where does it start? It doesn't start at 0, 0. It starts off the x-axis, meaning like up at it, above it or below it. So the fact that it does not start at 0, 0 means that it has to be a cosine curve. Now figure out your amplitude, figure out your frequency. So in this one, it also goes up to 3 and down to -3. So I have the same amplitude of 3. All right, but now look. This is from 0 to 2 pi. How much of the cosine curve are we looking at? Well, we're only looking at half of it. So that would be a 1/2 right there. And there you go. Right. The last one that I would like to do with you, we're going to skip 5, is 6. When I talked about word problems a second ago, here's an example, just one quick one so you can kind of see where we're going with it. It says the height of the tides can be described using a sinusoidal model. Yes, that's a word. Of the form of y equals a cosine and so on. So you might be like, they just said sinusoidal, but think of it, cosine is literally cosine. So anything sine or cosine is considered sinusoidal. Right? It says if the high tides are separated by 24 hours, what would be the value of B in the equation? All right. So think about the height of the water being, high tide, and then the water drops down and then it comes back up. So you can kind of see how it fits a cosine graph. It says if the high tides are separated by 24 hours, so here's 0, here would be the number of hours down here. So 24 hours later, it's back up to high tide again. You got to think, what is that 24 representing? Well, that is the length of one cycle, which is better known as the period. So the period would be 24. So when it asks what's the B or what would be the frequency, set this equal to 2 pi over B. So now instead of calculating the period, we're using the period to calculate the B value. You can simply throw that over 1 and do a little cross multiply. So 24B would equal 2 pi, divide both sides by 24, and then just simplify. We would get B over 12. Always leave things as exact as possible. So I wouldn't turn that into a decimal, just unless it says to. Leave it right there, call it a day. So that would be the frequency. Whew. All right, I hope you got all of that. As always, send me any emails if you have any questions. Get moving on those homeworks, and you do have a catch-up day tomorrow. So take advantage of that and then get your homework sent in. Thanks, guys.